Welcome to our discussion of Lab 5, our pre-lab discussion. Now, Lab 5 is another exciting lab, especially from an analytical perspective. Last lab, when we did the precipitation, the selected precipitation, that was a qualitative analysis. We were just trying to get an idea of what kinds of ions are in a particular solution. In today's lab, it's a quantitative analysis because what we're trying to do is we're trying to find out the concentration of the acetic acid solution, our sample, and we're going to use something called titration to do that. Now, before we start, just an opportunity to familiarize ourselves with the equipment, the apparatus that we're going to be using in this lab. We've got a pipette, all right, a pipette, which would be a device for measuring specific quantities of a solution. So in this lab, we're going to be trying to determine the concentration of the acetic acid solution, and we're going to use the pipette to transfer 10 milliliter samples. So this is our pipette, and we're going to use it to transfer 10 mil samples into an Erlenmeyer flask, right? It's also called a conical flask. And that's where the reaction is going to take place. So that's going to be one of the first steps. So the Erlenmeyer flask or the conical flask is that that piece of glassware there. So what you want to do is measure out exactly 10 milliliters of the sample that you're going to be analyzing. Next, we're going to put in the other reagent, but we're going to put the other reagent into something called a burette. And a burette is a piece of glassware that delivers precise volumes of a particular reagent, and it's got a control here called a stopcock, and what you can do, you can use that to actually regulate the flow of the reagent. So in this burette, we're going to be putting our reagent, the thing that we're going to be reacting with the acetic acid, and in this case, in this lab, it's going to be sodium hydroxide. So our sodium hydroxide is going to go here, and of course the sodium hydroxide is not a purplish or pinkish color. It is colorless. So we're going to put our sodium hydroxide in the burette, and we know the concentration of the sodium hydroxide. All right, we know that it is 0.500 moles per liter. So what the burette does is it enables us to add a precise volume, a measurable volume of sodium hydroxide to the analyte, to the acetic acid. And once we've added enough so that we've neutralized the acetic acid, then we would stop the flow of NaOH, and then we could determine exactly how much NaOH we added. So once we open up the control on the burette, the material is going to flow out from there. Okay, so again, there's that device that allows us, regulates the flow of material out. We're going to start off with our sodium hydroxide solution at a particular height in this column. Now this column has calibration, so you can take a look. All right, that's supposed to be an eye, so I can see some of you probably laughing at this. But you want to make sure that at eye level, right, you can actually see the meniscus. Remember, the meniscus is the bottom here, so you're going to have to drop your eye level a little bit so you can see the meniscus. That's what you want to see, and that'll tell you your initial volume. We're going to call that VI. That's the initial volume that you're starting with. You're going to have your analyte in that conical flask underneath, and we're going to allow some of the NaOH that's in here to flow out. We'll open up the spigot. Now we'll talk about how we can determine that when the reaction stops in a little bit. But by opening up that flask, some of this is going to pour into this solution of acetic acid, and obviously the height of the column, the amount of NaOH in there, is going to decrease. So once you've reached that end point, once you've determined you've added enough NaOH so that the reaction has come to a stop, you've neutralized your acetic acid, you're going to take a look at what the final volume is. Okay, so again, put your eye level around the meniscus. All right, we want to measure at the meniscus, and that will be our final volume. So to determine how much NaOH we added, it's going to be, so the volume that we've added would be the final volume minus the initial volume, and that'll tell us how much NaOH it took to actually carry out this reaction. So we've talked about the pipette, the use of the pipette. We've talked about the use of the conical flask, the Erlenmeyer flask, the burette. Our beaker is just merely to contain our samples. So we can use our beaker for filling up with sodium hydroxide, so we can safely pour the sodium hydroxide in here using a funnel. All right, so carefully you want to use a funnel to fill up the sodium hydroxide. Now, how are we going to be able to tell that this reaction has actually reached completion? Well, what we're going to do is we're going to make sure that we add a couple of drops of phenolphthalein. All right, so a couple of drops of phenolphthalein need to be in our acetic acid. And phenolphthalein is an indicator, and it changes color once the pH is in this range, 8.2, I believe. And again, you can take a look at your data booklet, page 10 of your data booklet. Tells us that phenolphthalein, and we'll talk more about this in lecture this week, phenolphthalein changes color in this pH range, about 8.2 to 10. Below 8.2, it's a colorless liquid, but above a pH of 10, it becomes a really bright pink. In fact, you might even say it's a fuchsia. Hope you're impressed that I know that word. It's a fuchsia color. So what happens is, once I've added enough NaOH, keep in mind, both of these things are colorless to begin with. The sodium hydroxide, the acetic acid, they're all colorless to begin with. So is the phenolphthalein. But once I've added enough NaOH, we're going to start to see a color change start to occur in the solution. Now, as I add a couple drops, I want to swirl this flask. Okay, give it a spin to make sure that the reactants are mixing together nicely. When I swirl, sometimes that color, that fuchsia color, is going to disappear. But I keep adding a little bit at a time. As soon as you start seeing some color appearing, you want to make sure that you're adding your NaOH drop-wise, one drop at a time. And you're going to stop adding drops when you see a permanent color change. So this whole solution has got to be that fuchsia color. Now, you don't want to overshoot. I know it's a nice color and you think, oh wow, if I add more of this, I'm going to get a brighter color. It's going to look nicer. You just want to have that first permanent color change, and then you want to stop and determine your volume, the volume that it took to reach that end point. Now we want to do at least 3 trials that are within 0.5 milliliters of each other. Okay, so we want to have 3 trials, 3 within about 0.5 milliliters. And that way we know that we're consistent, we're getting hopefully reliable results. As long as the consistency is there within 0.5, we can average those 3 and use that to determine the concentration of the acetic acid. So then this becomes a stoichiometry question, because you would know not only the volume, not only the concentration of sodium hydroxide, But with the burette, you'll know the volume that you used as well. So again, we can use the volume and the concentration to figure out the number of moles. Once we've got a balanced equation, hey, we can use that to figure out the number of moles of acetic acid that was in here. And don't forget, we know the volume because we used that pipette to pipette 10 mils of acetic acid. So if we know the number of moles of acetic acid and the volume of acetic acid, we can calculate the concentration of that acetic acid. So that's the glassware, right? And an overview of what the lab's going to look like. So when you assemble your glassware, it's going to look like this. You're going to have a stand, right, that is holding your burette. Okay, so you're going to clamp your burette to a stand. You're going to put your reaction vessel, your Erlenmeyer flask, underneath, and that's going to contain, as I said, your 10 mils of acetic acid. The burette itself is going to contain your NaOH, and as I said, it's 0.5. That's what we were using, 0.500 moles per liter NaOH. And the purpose, once again, of that burette is so you can determine exactly how much NaOH you've added. And don't forget that in your acetic acid sample, you have to add a couple of drops of that indicator, phenolphthalein. If you don't, these are both colorless solutions. You're not going to know when the reaction comes to an end. The first trial that you do, you don't know what the volume, how much volume of NaOH is required, so you might overshoot that a little bit. So in most lab analyses, you do about four trials because the first one you're a little bit off. After the first one, you get an idea of how much volume it's going to take for this reaction to stop, and you can start to go much slower as you approach that volume. So you'll get much more precise results. So that's how you're going to be setting up your glassware. And when you're finished your reaction, as you're dropwise adding your titrant, known concentration, into the solution, there's an indicator in there. You should have this nice bright color at the end, the fuchsia, the nice color at the end, and that lets you know that you've finished that reaction. And then, at that point, you've got all of the information you need to calculate the concentration of the analyte, the acetic acid. Now, every time you finish a trial, the material has been neutralized in the Erlenmeyer flask. So what you can do is you can rinse out the flask very well, so get rid of all of the reactants from it. It can go down the sink. And then you can use the same flask, put in your 10 mils of acetic acid, and run through another trial. All right, now we're going to talk about in lecture this week why we chose phenolphthalein. It depends on the nature of the type of acid and the type of base that we're reacting. And from what we talked about last week, you know that we're reacting a strong base. NaOH is a strong base. So I'm going to put SB here for strong base. And you know that the acetic acid that is in here, acetic acid, is a weak acid. So we'll talk about why we used phenolphthalein as an indicator and where the end point of that titration is, what the pH is when we've added equal amounts of acid and base. So there you go. I hope you enjoy this lab, and we'll chat more about it during lecture this week also. Take care now.